Welcome back to the Zoom Chemistry Hub. Today we are diving into one of the most important titration experiment, the determination of water hardness using EDTA. So stay with us and don't forget to like, subscribe and share this video. So first we will introduce what is the hard water or what is the hardness of water. Water hardness is caused by the presence of calcium and magnesium ions in water. It affects soap efficiency and leads to the scale formation in industry boilers and is measured in ppm or milligram per liter. There are two types of hardness, temporary and permanent hardness. Today we will determine the total hardness using a complexometric titration method with EDTA. Now the question is that why we use EDTA in this titration process. EDTA is the ethylene diamine tetraacetic acid, is a chelating agent and it forms a stable colorless complex with metal ions like calcium ion and magnesium ion because it forms a 1:1 complex with these ions and it's a perfect for accurate titration. Next, in the titration process we use the reagent. So here what you need for titration, that is the standard EDTA solution which is already prepared in the lab, that is 0.01 molar EDTA solution. Ammonia buffers having a pH of 10 to maintain the pH. Eriochrome Black T, that is the indicator. In free form it is a blue color, and the water sample. And what is the principle of this titration? At pH 10, the Eriochrome Black T form a wine red complex with metal ions, that is calcium and magnesium ions are present, and the Eriochrome Black T form a complex with these metallic ions. And after this, water having Eriochrome Black T is treated with EDTA. Then the EDTA binds the metal ion more strongly and releasing the indicator and causing a color change from wine red to blue. So this marks the end point. Now we will discuss the procedure of this titration step by step. In the first step, we take the water sample using a pipette to transfer the 50 ml of given hard water into a conical or titration flask. And in the second step, we add buffer and indicators. We add 2 ml of pH 10 buffer, and here the buffer we use is ammonia, that is ammonium chloride, ammonium hydroxide and ammonium chloride. It is the buffer and its pH is 10, so it will maintain the pH of this solution up to 10. And then we add 2 to 3 drops of Eriochrome Black T indicator. As we add 2 to 3 drops of Eriochrome Black T in this sample, in this water sample, then the color of this sample is turned into wine red. The original color of Eriochrome Black T is blue, and when we add in the water sample, the color of the water sample will turn into wine red. Then we fill the burette with the standard solution of EDTA, that is 0.01 molar. and record the initial reading on the burette. In the next step, we perform the titration slowly and gently and titrate until the solution changes red to sky blue color. We stop the adding EDTA solution and note the final burette reading and calculate the volume of EDTA which is used, and we have a formula for calculating the volume of EDTA, that is the final volume which is used minus the initial volume which we record at the start. And in the next step, we calculate the total hardness of water in ppm by using the formula of hardness, that is hardness in ppm is equal to the volume of EDTA used in milliliter multiplied by 1000 divided by volume of water sample in milliliter. And for example, in this experiment, the volume of EDTA which is used, that is 15.2 ml, and we take the sample of hard water, that is 50, so we write the value of these two, that is 15.2 multiplied by 1000 divided by 50, and we will get the answer, that is 304 ppm. And the final answer is that the total hardness is 304 ppm as a calcium carbonate equivalent. So the overall concept is that water hardness is mainly caused by calcium ion and magnesium ion in the water. So these ions form a stable complex with EDTA, ethylene diamine tetraacetic acid, which allow us to determine their concentration by titration. We have a quick summary of EDTA titration reaction, that at the start the metallic ion react with Eriochrome Black T and they form a metal complex, and here the color of this EBT metal complex have wine red color, and during the titration EDTA displaces EBT and takes its position, so the color start fading, and at the end all the calcium and magnesium ions bound to the EDTA and the color is changed totally from wine red to sky blue. That's for all today, the learner. If you think this video is helpful for you, please like, subscribe. Thanks for watching.